coding. So here we connected. So we created or we allocated field memory locations for the data item struct. This is the first data item struct we allocated. Then the first data item would have the next item, which we also allocated. And the next item will have the next sibling, which will also allocate till I don't know how many times, 1, 2, 3, 4, 5 times. Then we declared a cursor variable that will store the addresses for one item to the other item. As long as the cursor variable is not null, this means we're not still at the end of this link. What I want to add is we forgot to set the value field. Actually, this is even without the value field like that, this is still a list. It is still a list because each data item stores a reference for the next data item. And the actual data that the struct store. So the data, the struct acts like, let's say, a wrapper around the data. So we can define a data field like that. The type can be a string, or it can be an integer, or it can be a floating point number, or it can be even another struct. So this thing, the data item field, the data item struct, we can rename it to something like a wrapper. Let's say like that. So the wrapper contains the data we need, and to get the data, we have to jump from one wrapper to another wrapper. Okay, let's rename things back. So we have a data item and the values stored in the data item, we're gonna set them. So for the first one, we have first, the value is equal to 1. And now we allocated a second data item, which is the next memory location. So we can store the value 2 here. And here we start with the first item. The value is 3. Oh, sorry. This is the next to the next. And also here we have the next to the next to the next again. We'll have a value. So I think this is the principle, and it's kind of what we understand now. So the struct acts like a wrapper around the data we want to store. So 1, 2, 3, 4, and 5. Then let's go in the loop, printf cursor value. So the cursor use the addresses for the next items to loop through the list. Let's compile this code. Oh, there is a segmentation fault. This is probably because of this line. We try to access a value field while the next item is set to null. So there is no next item. I'm gonna delete that. So we want to access the value for this field. And in the terminal, you can see that we have 1, 2, 3. I can see a 4. Um, 1, 2, 3, and there is no fourth item. So which means we lost these allocations here. So we lost the fourth item. What we had to do is to say, okay, let me check again. 1, 2, 3, 4. So we have next, next. The next item has a next element. And this one also has next, 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 next equal null. And the value is 5. I don't understand what is happening. 1, 2, 3, 4. Oh, yes, there's actually 4 items. Need to delete this line and that also. Okay, let's try again. So 1, 2, 3, 4. So we have to be careful on how we link those items. So once you know the address for one struct, you can save the address for the next struct inside the current struct. And the data you want to store can be an integer or whatever. So this is the manual way of doing it. Now, let's create functions that allows us to create a data item and a function that allows us to add a data item. So I'm going to add a function named create. So this function will return an address for the newly created data item. And the data item store a value. So the function is going to receive the value for the data item once created. Then we define a variable inside the create function. I'm going to say new data item malloc size of data item type. So the malloc function will allocate a memory locations in the computer memory and return the address so that we won't forget the locations for that allocated memory space. Then the next thing is we say data item. We set the field value to the value provided and the new data item. The next item, we're gonna say the next item is null. Then we return the new data item. So the value stored in the new data item variable is the address. It is an address, so the address is the one we're returning here. Now, instead of typing malloc size of all these, we can just call the create function. So create, then we say value 1. Then the next one will be create. This time we pass in 2 for the data item. And here also, we don't need to access the value field. We can set it directly from the function call. The same thing goes here. So create 4. So it works because this create function, once the new data item is allocated, the value is set and the next item is set to null. So this will return a new data item with value 1 and next set to null. Then this will set the next item to the new item and so on. And when you run this function, we still got the same result. I'm going to compile it and run. 1, 2, 3, 4. So that one works. Now, what if you want to create a function that add a data item? Let's say it will, let's say a function called, let's say, append. I'm going to call it append. And it will receive the first data item and the value to append, because we cannot add a new data item without knowing the first item. So because we need to jump from the first item to the next item till we find the last item, then we append it. So I'm going to say first data item like that. The value, we're going to say the value is an integer data type. And here, from inside this append function, we cannot do something like first, next, because we don't know what is the last element or how many items this list or we don't know how many next element are in this list. So what we want to do is to define a cursor variable that we'll use to look through the list, then check if the next item is null or not. Because if the next item is null, that means this is the last element, and that also means this is also where we need to append the new item. So for that, I'm going to define a variable named, let's say, last. And we're going to set it, I prefer the name cursor. Okay. Then what I'm going to do is we're going to say cursor equal the first item. Then while the cursor next item is different than null, it means it is not the last. So we're going to say the cursor is equal. We're going to move the cursor to the next item until we find an item that doesn't have a next item, which means it is the last one. Then what we do, we say, okay, since we've got the last item, we can now create a new item which will hold the value. And that's it for the append function. We're going to get back on this function to add some other features, but for now, this is good. So here, instead of typing things like that, we're going to do it dynamically using the append function. So I'm going to delete this line and replace them. So that one would be append. We pass in the first. Then we say we want to append the value 2. Then append, we pass in the first. We want to append the value 3. Append, we pass in this first item. Then we append first 5, append first 6, append. So we can append as much as we want, because this function is quite flexible. Now let's compile.
Excuse me, Mohammed.
Yes.
Uh, how is it creating memory for the for the data items that we are creating, we are appending to the list?
Yes. Here we have this. So for the first data item, we call the create function with the value 1. And the create function, what it does, it will allocate a memory location for one data item, then set its value field to the value we passed in. Then it will set the field next to null, then return the memory address. So for the first data item, if you look at the right side of the screen, we have, I'm gonna say this is, so this one has, so we have this memory location with an address and a data field, and the data field stores something like a value and the address for the next element. So we created the first item in the memory. I'm going to, let's say like that. So we created the first item in the memory. I'm gonna add some custom things. Then this function returned it, and it was assigned to the variable named first. With the star sign, that means this will hold an address. So an address to the actual memory location. And then we call the append function, then passed in the address for the first data item that has been allocated, so that the append function knows where is this first data item in the memory. And what the append function does, it will look for the last item in the, it will look through the next items till it find one of them that has in the next item. So it can conclude that this is the last one. For example, when we created the first item, if you look on the right side of the screen, the next item was set to 0, and the data value, the value field was set to 1. And in the append function, we create this cursor function, and we said that while the cursor next is different than null, which in this case, the next is equal to null, then the loop will stop. So here we want to set this to the address for the next item. So we call the create function. The create function will create another field, which will have, let's say, another memory location, which will have the field value and the field next. So the next for this first item would have an address set to the address of this newly created item. So here we can say, let's suppose that the address for this is equal to something like 0x11. So the next item field will have the address set to 0. The next field for the first item will have the next field set to 0x11. So which means once you know the location for this first data item, you also know the location for the next data item, and so on. Is it okay for now, or there is still something to clarify.
Yeah, it's okay. I hadn't seen where you had the malloc function inside the
Ah,
structure.
yeah, it is here. So I'm going to compile and run this code, and still we have this 1, 2, 3, 4, 5, 6, 7, and actually it is more flexible. It is more flexible because we type in less code and we can call the append function whenever we want. So now we're going to make things to confuse you a bit by changing the names. For example, these things we called first, I'm gonna call it lists. So when you see that list, the names might cause some confusion, but still it represents the first item. So this is a list. Okay, but I want to add some other things. We want to say this time we're going to set this variable to null. We're going to set this to null. And we're going to say when we call the append function, the append function should be able to know that this variable here is set to null, then it needs to change its value. So I'm going to say, okay. So here the append function will receive the address for this variable named first. We're going to change the prototype of the append function. We're going to add another start sign. So the start sign tells that this variable here, I'm gonna call it P first, hold the reference to a variable that can hold a reference to a data item type. And here the cursor, we're gonna set it to something like that. And that's it. So what is going to happen is we need to first check if, so there is one conditions here. This can be null. And what I'm gonna say is if the pointer to the variable that hold the first item is equal to null, then it is the first element in the list. So we're gonna create an item and set the first element to the newly created item, but else we look for the last item, then we set it's next to the new item. I'm gonna format the document a bit. So here, what we're going to do is to pass in the address for this variable here so that the append function can check if it's null. So if it's null, it will set its value to the new item. Else it will just look for the last item, then set the next to the new item. I'm gonna say the address for this first item, the address for this first variable. And still, when you run this code, it will work, or it should work. I'm gonna say append first one. and append. I'm going to add other elements, let's say 8 element in the list. Now let's open the terminal and run the code. Okay. And here you can see that we have 1, 2, 3, 4, 5, 6, 7, 8. So the logic is still there. We're still following the principles, but this time we just made the code more dynamic and more easier to use. So we're going to replace this code by another function called print. And the print function will receive the address for the first element, then display the items till the last element. So I'm going to define a function here. I'm going to call it print. Print siblings or print all. So this will receive the address for the first element. Then I'm just going to copy the code here and pass it inside this printf function because basically it's the same code. So we define a cursor that will allows us to look through the items. So we know the address for the first element, and from the first element we can get the address for the next element. Then here I'm just going to call this function called print all. So this function needs to know the address for the first element and will jump from one memory location to another memory location to display the value fields. Let's compile this code again and let's see. Yeah, it still works. So that's it. 1, 2, 3, 4, 5, 6, 7. So now we have a code that is very flexible. And I guess also we can demonstrate the same things. We can make a demo for double linked list. When you create an item, the item will store a reference to the previous item. Is there any questions for this section before we move on double linked list? Okay, great. Let's move on the next thing.